Whatever. Whatever. Making a W out of my fingers. Oh, so we're here again and stuff.
We're always here, as far as they know.
As far as they know.
In their little phones, hiding out and waiting to be activated with that little sideways triangle button.
Sideways triangle button.
We are everywhere.
We kind of are at this point. I'm surprised at how there are places we are that I didn't know were. You know?
Yeah.
Well, you would because you're the one who goes out there and puts them there. I'm Rai.
I'm Harland. Ubiquitous Grant.
And we are the Dawdlers.
And this is the Dawdlers Philosophy Podcast. We're going to talk about science, right? This time? Are we going to do some science? Or at least talk about people who do science?
You said doo-doo. I think we're going to talk about, I don't know how well we're going to do it, but we're going to talk about this paper I threw at you by a statistician from the 20th century whose name was George E.P. Box. And I guess, he was a big-time statistician, apparently, during his life and times. And he's famous for a particular kind of bumper sticker that you and I appreciate, and I think a lot of other people appreciate it as well. So much so that he was fond of saying it and writing it. He wrote it in many different papers and even a couple books, apparently. And in this particular paper that we both read is called Science and Statistics.
It's like the two greatest things, right?
Basically.
I'm trying to be excited for you because you don't have it tonight.
I don't. It's okay, though. You can fake it till you make it. But yeah, so this paper, out of the many, why choose this one, I suppose? When I've looked through and read his papers in particular, I'm not like a connoisseur and read all of George Box's stuff, but I've noticed that when he touches on this particular topic that the paper is sort of centered around, it seems to me like it's the most general of the bunch, I could be wrong. Other people will be like, no way, it's whatever the other ones are.
I don't remember.
Off the top of my head.
But this one just seemed like it also had a little more of a story aspects to it, and I just thought, well, maybe this one would be better for the both of us to go over. But even then, it still got a little too technical, I think. And you talked about glazing over a little, and I kind of, I agree. I mean, there's some glaze over aspects, especially when he's talking about this one particular science and statistics hero, if you will, named Ronald Fisher, who's a big deal.
That some of us may know as by the initials R.A. Fisher.
Yeah, R.A. Fisher. Thank you. I don't know if you can hear that, but that's Louisa howling, my dog. Because the sirens go by.
Oh, I thought it was because she heard us talk about Ronald Fisher.
Oh man, I wish I could be fully recording that, but oh well. Oh man, she is going at it. Hilarious. Anytime the fire trucks go by with the sirens, that's what she likes much more than like the ambulance. She never does that with them. Boy, she's really
Interesting.
going for it. Okay. Yeah, I guess you can't hear it, but whatever. So this is a little distracting having a wolf howling in your house. But yes. So gosh, I'm totally
Well, you mentioned that Box had a bumper sticker, but I don't think we heard what is on his bumper sticker yet.
I know, God. I know. Like it's always at that moment where I'm like, should I say it or should I just finish my thought?
Oh, okay. Well, yeah, if you want to
You know.
keep it in reserve to drop on us in the proper moment, that's allowed.
This is the proper moment right now. In summary, the main it's a sort of a summary of what he said because he said it in lots of different ways. But the bumper sticker is
all models are wrong, but some are useful.
feel me?
Where can I order this? I like it.
I know. Is it on Amazon?
We need to start marketing all of these bumper stickers from obscure statisticians and philosophers. And
I it's funny. Maybe this is uncommon in some areas. I mean, it wasn't uncommon, I guess, in my experience with, other science people, especially when I was in school and stuff. But yeah, that's the bumper sticker, and that's kind of something that he was fond of saying. In particular, I think that all models are wrong is the main component. And then he was fond of saying, but hey, we can use some, or whatever. So
yeah, and so you're saying that was sort of his refrain that he would write in every paper. I picked up on it in this one too, because of course that's a lesson that I've been trying to argue for a while and gets a fair amount of resistance from some people. But yeah, in this paper I noticed that he just dropped it. It was just like, here's a new heading, a new paragraph, all models are wrong. Bam! Like, whoa. And he didn't really go into it or explain it or argue for it. So it makes more sense to me now to hear that that's kind of Box's deal. That's his little catchphrase.
yeah.
He staggers through Seinfeld's door and he's like, hey, everybody, all models are wrong and some are useful.
Yeah, totally.
And then the crowd cheers like, yeah, there it is.
This guy's the best. Yeah. But interestingly enough, he goes on and on about R.A. Fisher and what a great guy he is and everything. And one thing that I learned about Box is that R.A. Fisher was his father-in-law.
He didn't alert me to that in the paper.
No, it's like, can you imagine like underneath like conflicts of interest at the bottom of the page? He's my father-in-law. I call him Dad on Thanksgiving or whatever. They're British.
Yeah, a little bit of nepotism here. This was a very pro-Fisher paper.
Mm-hmm. But, Fisher, he doesn't need his son-in-law to help him any, in my opinion.
Oh, yeah, he's such a big whoop that even I, all the way down the hall in the basement of the Humanities building, have heard of him.
Exactly. Right. And so I don't really have much of a format here, except for to say that we've, read this paper. It's sort of a hodgepodge. I thought it's kind of just sort of like an old man throwing things out there. I don't know how much longer George Box lived for after, this particular paper was published, but I think he at least had a couple books that were like textbook style or whatever that were published in the 80s. And this was published in 76, if I didn't already mention that. And so that's just, something that we should always, keep in mind when talking about the paper as well, is that it's not like the kind of artful construction that the last paper we talked about, which was by that T.C. Chamberlain guy about the method of multiple working hypotheses. That one was this like paper that just unfolded really nicely, and
Episode 17.
Nice. But this one's just kind of like bloop, 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 and then he goes into his daddy, and he talks a lot about him.
Would you say that this paper was about, if you were giving your book report in 8th grade, the scientific method and how it interacts with mathematics, specifically statistics?
If I was an 8th grader, probably. But me now would say it's really about the statistics as sort of an interface between different parts that are very important to science. So theory and practice is what he says often. Another person might say data instead of practice, but whatever. I think practice is fine. How does that sound to you?
Yeah, we could say theory. He says theory and practice. We might say models and data, right?
Right. But it's science and statistics. I don't even know if that's the best. I'd almost want to say it's statistics in science would be a better title for this one. But anyway, whatever.
Mm-hmm. Yeah, that would make sense.
I think one way we could do this is you have a number of questions and things that are important to you. And I thought maybe we could take that strategy where you kind of have your thoughts about certain points and maybe ask me what you think or things that you think need to be addressed by the scientists in the quote unquote room.
Wait, what?
All right, you giving me the wheel, huh?
Yeah.
I'm going to go off-roading, and you're going to be like, where are we? What's the... And I'll be like, you said you didn't have a plan. You didn't care where we ended up. You brought your tent? Fuck it.
Yeah.
If I'm in charge, I like quotes. You know that. So I'm going to read a goddamn quote. I like his tiny little introductory paragraph where Box describes what, to him, the scientific method is. So the quote goes,
Aspects of scientific method are discussed, in particular its representation as a motivated iteration, in which, in succession, practice confronts theory and theory practice. ... The ability to devise parsimonious but effective models, to worry selectively about model inadequacies, and to employ mathematics skillfully.
So I really often like particular turns of phrase, and to describe science as the ability to worry selectively, I quite enjoy and never had thought of before. But the general concept of, well, the family of concepts around anytime you find some anomalous data, there's an indefinite number of possible ways to explain it. Theory is underdetermined by evidence. All that kind of talk, I think, is what Box is describing by, well, yeah, that's a skill that scientists have. We learn how to worry about the relevant aspects, or something like that. Does that make sense?
That makes sense. I mean, often I always heard the term simplifying assumptions being made in that sort of same vein, where it's like, well, what are the things that we can, select out and essentially worry about that we have some degree of control over. And that means then if there's something that you just have a difficult time grappling with, what can you do to kind of take a step back and work from and potentially have some inference capabilities to work from?
Another thing I like to do is tie together threads from previous episodes. So this one, I think we can tie, as you already mentioned, to episode 17 about multiple working hypotheses, and I think also to some of the remarks in, it was episode 15, right, where it was philosophy and science.
Mm-hmm.
What are the two, trying to define them. So in this case, the things that I would want to define would be first science and then second mathematics, because in this context, I think that's what Box is emphasizing, that we've got this scientific method and somehow it involves skillful employment of mathematics. the way that Box describes science as this motivated iterative process between theory and theory and practice, and we were saying between model and data, is a bit like Chamberlain's multiple working hypothesis thing, right? It's at least the having one hypothesis. You go either out into the field or into the laboratory with your hypothesis in the first place. You use that to either abstract out a certain subset of data from the environment or to design your experiment. Box talks a lot about experimental design in here. Then you do the practice part. You accumulate your data, you run your experiment. Then in the light of what you receive, you go back to the theory model side and update. Right? You worry skillfully about why did I receive the data I received and what might be an improvement of my hypothesis. So then you've bounced down to that side again and you reformulate your hypothesis and then you bounce back to the practice side and you run another experiment or accumulate some more data. Is that a fair characterization of the Box characterization of scientific practice?
Yeah, I would say it's a fair characterization, and I would say that one of the tie-ins would be to, I guess, episode 15, the one, Rolling Wall of Fog, I think. Is that the one with philosophy and science? I used science as a process, talking about selective process by David Hull, and he talked often about how scientists were unwilling to just say, well, this is my thing I'm going to hold fast to. And you were like, hold fast. And I was like, well, they want it, it's provisional. It's not going to be something that you just end on and then that's that. You're going to, maybe put something out there. And then over time, you're going to be trying to work out how to test it and how to work it out. But it's not something that is super concrete. It's more fluid.
Mm-hmm.
And I think that's sort of very similar. The feedback process is much more fluid, because one of the things that isn't said by Box is that some of these iterations can be really quick, and they can be ongoing and just like boom, 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 like they're just not, it's not like there's this like, okay, I have my hypothesis. Now I'm going to, take each little step and work my way and do everything perfectly and precise and all that. Sometimes there's, a little bit of work going on over on the, by a student, and then there's some little bit of work going on, and maybe they'll take apart the hypothesis and look at various parts of it and try and figure out, what they can do, in a sort of iterative, a parallel incremental way or whatever.
Sure. I would even say that the process of trying to get a glass of ice water at your first night at an Airbnb would fall under this rubric, right? Well, I think I remember the kitchen. You got to go like downstairs, and then it was the third door on the left. And then, okay, now I've made it in there on my hypothesis. Oh, now it's okay. There's a sink and there's a fridge. Water out of the fridge is usually better than out of the sink. I think I might go over there. A lot of ice machines don't work. I'm going to push the ice button. Blah, blah. It's just a constant flipping back and forth all the time.
Perfect.
That any of us are doing as we go throughout any daily process.
Yes, I very much like that. And that's kind of why, it's sometimes, I wouldn't say it's informal, but it's not like supremely official formal. The reporting will be there, but will be there in the sense that it'll describe what to do, to repeat the thing or whatever the experiment or whatever the data project was, etc. But in general, it's these are human beings doing the work. And so, they're going to be like, I have this idea and then I'm going to work it out. And then it's just, going to go back and forth iteratively. Nice.
So if that for tonight is our definition or our picture, general picture of what science is, what is the other side? What is statistics a subsection of mathematics? What is math? What is statistics?
Well, of course, statistics, if you go around trying to find definitions and stuff, there's a lot of them, And so given what we've already talked about, I guess the one that I kind of like the most is this book that it's not even a book that I had as a student. It's a book that my wife had in one of those classes where it's, Science Light or whatever. And it's by Jessica M. Utz, and it's called Seeing Through Statistics. So it's kind of one of those things that just sort of a lot of, descriptions, no math, like it just, anyway. But she describes statistics, which I kind of like, is
a collection of procedures and principles for gaining and processing information in order to make decisions when faced with uncertainty.
And so I kind of think that's out of the ones, all the ones that I've looked at, that seems like at the time when I was looking at these, that's the one I like the most. And then now that we've talked about this motivated iterative process we call science perhaps for the moment, I kind of think that's good because you're making decisions, you're processing information, you're faced with a lot of uncertainty because you're not exactly sure how to go down to the stairs. You think it was over there on the left once you get down to the foot of the stairs, but you're not quite sure, like it's that kind of, I kind of think. And so in some ways it doesn't have to be, in my thinking, absolutely underneath math. It's just a kind of maybe a methodological approach to helping make decisions. And the science is the feedback thing that happens.
Okay, this is interesting to me, and I would pause on it for a moment if that doesn't throw you off too much.
No.
Because and disclaimer, I don't know anything. I know very little about mathematics, and what I do is mostly from the outside. And statistics, I don't know statistics except for like playing poker or so, vaguely, and like 2 + 2 is 4 level. So to those of us who are outside the disciplines, does it make sense to you that we would think that statistics is a certain type of number shuffling, that it's just math about populations and distributions and probabilities and all that kind of crap?
Yeah.
But your thought about statistics seems to be more broad. And maybe you could throw that definition at us one more time and say a little more about what your version is.
It's not my version, but I like it. Can I embed it in some of the actual discussion that she has, this Jessica M. Utz?
I like more from Mutz.
Okay. Quote! Anyway.
The word statistics is actually used to mean two different things. The better known definition is that statistics are numbers measured for some purpose. A more appropriate, complete definition is the following. Statistics is a collection of procedures and principles for gaining and processing information in order to make decisions when faced with uncertainty. Using this definition, you have undoubtedly used statistics in your own life. For example, if you were faced with a choice of routes to get to school or work, or to get between one classroom building and the next, how would you decide which one to take? You would probably try each of them a number of times, thus gaining information, and then choose the best one according to some criterion important to you, such as speed, fewer red lights, more interesting scenery, and so on. You might even use criteria on different days, such as when the weather is pleasant versus when it is not. In any case, by sampling the various routes and comparing them, you would have gained and processed useful information to help you make a decision.
End quote.
No, God! No, God,
Okay.
please, no! 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 No!
I think I see where it's going. To me, the bumper stickers part of the definition felt too broad, but that's the matter of taste, I suppose. Very broad. And I imagine you'll say, yeah, it is. Because it even involves determining what the optimal route to drive your kid to school is, and it's involved in most things that we do.
Mm-hmm. So in the cycle, so for those listeners out there who can't see the pictures that George Box created, he has this kind of circle, if you will. It's not really a circle, but it is a sort of loop where you start out with a hypothesis and then you go through a process of deduction where you get out of it this notion of, some consequences that you, or expectations you would have of behavior of the system that the hypothesis is about. And you would compare that to some facts. And then from that, you would get what he's calling an error signal, where you compare the consequences to the facts. And then from there, you'd go through a process of trying to, from the, this discordance or whatever, you kind of generalize a little bit and maybe modify your hypothesis. And then that would replace the initial one. And you'd start the process over again. Statistics, in my thinking, is just that point where you have the expectations and you're comparing them to the facts or whatever, the data that you collected, and you get that error signal. That's statistics. Is that part of the loop?
Would you say that to do statistics, even in this broad sense, requires some sort of loop or multiple iterations?
Yeah, I mean, it would be very similar to that idea that we just talked about with respect to science. So it would maybe even be, to an extent, it would be like, almost like embedded, almost a fractally kind of thing. Like it's sort of a loop within a loop that has a very similar kind of iterative back and forth process. But I will say there are different kinds of statistics that do this kind of thing. For instance, like Bayesian statistics takes into account new information as you go around calculating the probabilities of events given other information. So it's still going to be there, but the actual whole process, it's like a tool that acts on the facts. Sorry. And then you go through with your actual process of trying to create an idea that is beyond just simply the back and forth or whatever. But what you were saying about going to get the glass of water, I think science is that way too. Like, I think it's also kind of like, yeah, I'm going down. But then within that, you can use statistics to help you make those decisions as you go along.
Because I'm invoking other experiences that I've had with other refrigerator water and ice machines?
Yeah, I would say to an extent there is that. Your decisions to go, well, I've, got this prior experience that I'm going to use now in this situation. Maybe say the hypothesis itself is, getting, if I get a glass of water, my thirst will be quenched or whatever. Something. It's hard when you use one scenario and you try and apply it to everything.
Yeah, now we're back into a classic philosophical problem of how do you know that the next piece of bread that you eat will be nourishing instead of toxic. But we're not talking about that tonight. Given that broad definition of statistics, how would you say it interfaces with science in Box's sense of motivated iteration?
Well, maybe I'm not understanding your question, but I was thinking it has to do with that loop that he came up with, where you have a hypothesis, goes through a process of deduction where you end up getting some expectations about the hypothesis, consequences. You compare that to information that you've collected. Any, incongruence or whatever that goes on between your expectations and what you actually collect then goes into the process of kind of generalizing about what those differences are in the data and expectations, and then coming up with a new hypothesis based on the new information that you have, and then starting that process again. Is that not what
Could
you
meant? Put in bold the part of that which is statistical, or are you saying It's that entire process. That just is statistics.
No, the bold part would be the comparison of your expectations based on the hypothesis to the data you collect. And that any particular methodologies of processing that information to be able to make sure that you understand that the error signal you get or whatever is as good a signal as you can trust or whatever. And then you can go from there to start the process over again.
Okay, so that's this step at which statistics plays its most important role, not necessarily exclusively, but comparing my expectation with my results.
Well, with the information that I collect, yes. But you may do a data analysis on the results based on the expectations that you have, and that's where, say, the mathematics comes into play. If you're doing if your data is quantitative. If your data is not quantitative, you might use other kinds of methodologies to deal with qualitative data. But this is all very quantitative today. It's not qualitative, but just know that there's another world out there of people doing qualitative data stuff, and you can use
what
something
would be an
called,
example of that real quick?
Like maximum variation sampling, and that's sort of where you try and understand as much of the dimensionality of your problem set or whatever is possible, and you try and find an example of each one of the different changes in the variables or whatever, but you don't have a mathematical equation to work with, and it's the data you're getting is not quantitative. It's not a measure or even a particular observation, in that you've written down category 50 times that elephant did this or whatever. You know what I mean?
The maximum variation sample might be, just to use a simple example, you take the population of Oregon and you want to find the tallest and the shortest human beings currently residing or who have an Oregon driver's license. And is that maximum variation? And you're saying that's not statistical because there's one and only one of each extreme.
I think to an extent it might be somewhat statistical. You're just trying to find all the extremes, because statistics is often quite a bit about extremes. And that's kind of another thing about statistics, is that you're trying to understand where you fall within the variation of the data set that you have, where your data actually falls, or your particular event or history, or not history, but your particular event in the context of all the data. And that's but that's, maybe I'm throwing too much confusion in there. I would say you could probably do some kind of statistics on qualitative data. It's just not going to be math based. You're not going to be getting averages and variance, and you're not going to be doing those kinds of tests necessarily. And so one of the ways you want to kind of talk about the problem is you might use something like maximum variation sampling or whatever, where you can talk about at least all the various extremes that can be collected, and have at least as fleshed out a picture of the problem as possible. But we've spent too much time on qualitative already, because I think this one's all about Fisher and statistics, and I do think that it's a better thing to talk about statistics in the quantitative sense than in the qualitative one.
Okay. And that's how Fisher was working with it, you're saying?
Yeah. But
do you want to talk about who Fisher is and why he is the exemplar in Box's paper?
Sure. Fisher is interesting because, as far as Box would say, Fisher was a scientist, kind of as general as you could be. And he was just super inquisitive, very curious. He came out of Carl Pearson's lab, and Carl Pearson is another one of those big time statisticians. But I think, as far as I can tell, Pearson was much more of a pure statistician, numbers guy, than even Fisher was. And Fisher had a comfortable existence in Pearson's lab, but he decided to go to this particular research station, which I always have a hard time saying the name of. It's kind of like Worcester, but it's Rothamsted or whatever. I don't like that word, but anyway, I just don't. So he went to this Rothamsted place, and it's here where he became the R.A. Fisher that everybody knows. And so he joined Rothamsted in a sort of it's a sort of like a temporary position in a way, where he was just they were kind of being, I guess they were really being crazy at Rothamsted, and they were going to have themselves a statistician. And I guess that was revolutionary at the time to be a research station that did that. And their primary focus was agricultural research, trying to, get people fed and do it right. And so he just kind of, in conversations with people, just would get himself kind of embedded in other people's research, and then could from there kind of work off of their research and into coming up with some of his own ideas. And in particular, his primary focus was how to quantitatively address and handle these problems as successfully as possible. And out of that work came quite a number of methods that are still used today. And that's sort of another reason why he's sort of a big deal, is because he was able to come up with ways for people to analyze their problem by collecting the data and assessing how much error there was, say, between the data and what the expectations were from the hypotheses, something known as hypothesis testing. And it was before really the computer age had taken off. And so, you really, these people used tables. They still do. I mean, but, these sort of tables where, you can go look up your value that you get from this particular calculation, and given other parameters, whether there be things like, I won't even get into it because you're going to be like, what is that? And I'll be like, shut up. But you can look up to see whether or not your your test result was, as they say, statistically significant, whether or not you think you should then make a decision to say, yes, we will now grow more of that wheat in that way or whatever. So that was, part of it. And so that's kind of partly why he's a big deal. Another part is, after all this, I believe, he's kind of one of the people that first, show how genetics and natural selection can be joined together. How you can see, and in a way, what that did was it made essentially a mathematical formulation of natural selection. And it was a paper in 1930 that he put out. And of course, I can't ever remember it. There's probably something as simple as like genetics and natural selection or something. And he was very prolific. Like, he just was super, like, always pumping out volumes of work, And this guy Box talks almost lots of detail, as if he spent quite a bit of time studying his father-in-law's works. I would, if I was going to have Christmas dinner, and if I was a statistician. So, so there's all of that kind of going on. And so he's kind of just a big deal in that sense. But it's funny because some people might say he's just a statistician. Others might say he was a geneticist. Some might say he was, just a biologist or whatever. So he did a lot of stuff. I think he had the pleasure of being at the very beginnings of something. Number one. And number two, he was also very ingenious. And so he was able to essentially set the table that everybody else kind of later would kind of sit at and kind of live by, so to speak.
And why Box brings him up, in part, I think, is to argue against those who might paper Fisher as being a mere statistician. Box wants to emphasize, no, I think it's better to characterize Fisher as a scientist who did statistics sometimes. And what I recall from the paper is him going through a list of all these different ways that Fisher did applied mathematics, right?
Yeah.
Everything from well, you can find these little diaries where he like wrote down all of the weights of all of his children. Right?
Yeah.
He kind of obsessively, he had a bunch of babies and all of them on a schedule. He would weigh them all and painstakingly write it down and then do some kind of theory about how baby weight develops, or I don't know what he's doing. And then he goes out in the field and he's digging in the mud and in the cornfield or wherever, the wheat field or wherever he was.
Muck raking.
And he's a muck raker. So and that's what, I guess, for a box makes Fisher a scientist.
For sure.
In this, as you said, this is a bit of a almost biographical story form article. And as I recall, the way Box tells it, Fisher started out being what I don't know the technical term, but sort of a real world data accumulator. That he literally would go out into fields and say, all right, on this acreage, we used this type of fertilizer for this many years, and here's the yield. And on this one, we used just pure clean manure with nothing added, nothing else, and here's the yield of that. And it was very real world, whatever. But then he got apparently frustrated in various ways with the limitations of letting situations develop the data, so he became more of an experimentalist. Is that right, or what's the story there?
Yeah, that sounds roughly correct. And he definitely, the real story I thought with the experimental stuff was just that somebody had published something out of Rotham's, whatever the hell that damn place is called. I've forgotten already. Rothstein Station. Remember Rothstein? Or Rammstein. Fuck, whatever.
Yeah, I was like, I don't know, Rammstein? Yeah, I know that.
Sorry. That should be the song that plays after this.
You need to listen to that tonight. You're like all angry and...
Oh, for sure. Rammstein sounds like a good one to listen to.
Du hast mich.
What is this, Klingon? But anyway, somebody was like, hey, I think, if you had done that study, it would have been a lot better. And, you'd be, I bet you could come up with a good experiment or whatever. And it got him thinking about that. Like, yeah, I guess I should do some sort of experimental trials and things like that to that nature. And in a way, those are the things that I think really kind of gave his intellectual lineage, if you will, its real roots. You can see this kind of experimental design type stuff in even clinical trials today, with the idea of randomization and blinding and all these ways to kind of get at the problem, the statistician wanting to get at the front lines of like the meetings when you're about to talk about what to do with the science or whatever. He wants to be there right at the beginning, and then you can start to help cater how the experiments might go. Get in there first. Don't be somebody who just gets this data and has to work with it somehow, but really get in there in the beginning. And I remember actually one of his particular kinds of tests that he came up with. I remember a professor of mine saying, like, you could just do that before you go out in the field, run this particular kind of analysis. And that'll help you get a picture as to how you want to go about solving the problem or whatever. And it's called analysis of variance. And no, I don't want to get into it. I love the silence on the other end. Not even laughter. So there it is.
Force it. You just pause on it for a while. Say it in a couple ways, and then you'll make them laugh.
Anyway, so that was kind of the general, I think, approach. If I said any of this very well, it's just that you get in on the ground level. And I think he compared the statistician's role, or a person using statistics, as kind of more like the architect who's like, okay, let's make sure we build this part right, that kind of thing, so that it'll stand up later. We can really kind of help ourselves here rather than get all bogged down in the muck. Additionally, I think this is also kind of, the early 20th century. I think this is a big turning point for science. I think where you can really quantitatively not just simply measure something, but that you can take multiple measurements and structure and almost, I say maybe guide how they go in a way that you can then feel like most confident that you are comparing the data you've collected from, essentially having a data model, this experimental design of how you're going to collect it, so that you can feel most confident about comparing that to your expectations. Otherwise, there's a lot of shit that might be going on that you weren't keeping track of, and you're like, oh, fuck, I don't know if, these results really are going to be comparable to what we expect, because there's all these things that happened, and I can't trust that the data is as good as it could be, and so that's kind of part of, I think, what his work really kind of came down to.
I think I'm going to take a stab. I don't know that this is what you were saying, but you have a critique of experimental laboratory science that you have a danger of, quote unquote, falsifying nature by constructing artificial situations. In your fervor to isolate phenomena from extraneous causal influences, you can either fall under the illusion that you have succeeded, and now that which I am attempting to experiment on is isolated, when in fact, in reality, it is not, and there's some factor influencing the evolution of your system that you're unaware of, or that by removing certain factors from the phenomena, you have trivialized the results. That, well, yeah, you were able to artificially manufacture that situation in the laboratory, but that's not how it works in nature, and so what you have learned is irrelevant. So there's that line of critique. What I thought you might be saying is, statistics is one way of rebutting that line of critique by saying, well, the fact that we do it in multiple iterations, compare the results, analyze in different ways how they are similar and different, and try to figure out why they differed in the ways that they did. It's just the idea that, yeah, well, we ran it 1,000 times. So the quote-unquote same thing 1,000 times got these results, and we have different ways of analyzing them that might help indicate that we are onto something.
Yes, but the statistics part, in some ways, we've kind of moved on to the experimental design part a little bit. So I guess I'll just quickly first address the experimental design part, and then maybe we can move on to some of the statistics that might go into it after the fact. So say you have like a clinical trial. Well, first off, one way to maybe make sure that your groupings, because you want to see the efficacy of some kind of drug, some active ingredient. And you're going to just compare that to some placebo, your kind of quote unquote null, if you will. So one way you might want to try is by randomizing who goes into what group. That way you don't end up kind of with your own decision biases, just like accidentally putting all the blonde-haired people in there. Just you want it to be as mixed up as possible. So that way, whoever is getting the active ingredient and whoever is getting the placebo, that whatever variables that might go into biasing what ends up happening in the end, maybe the active ingredient works on blonde people better or something like, whatever. And you want to kind of get a sense, well, I want to address all people. I don't want to just, make a drug for blonde people or whatever. So you mix it all up with a random sampling by just setting them into the different groups. And then from there, say you also go, well, should the people know what they're getting? Maybe they should be blind to that. So they don't even know what they're getting. So you'll give the sugar pill to the one people and then, randomized group, and then the other arm will get the active ingredient, but nobody will know what it is that they're getting. Then maybe you could be like, do I want to know what they're getting? Maybe I'll do a double blind and I won't even know what I'm giving people. We'll randomize them. I'll just give to the different groups what, I won't know what it is. So that way you ensure that you're limiting as much bias into the initial part of the data collection process itself, right? And that's just a way of just like taking care. And then later, when you actually end your trial or whatever, then when you're doing the actual statistics, say you're doing an analysis of the variance or whatever it is, then you can at least be sure that you tried to take care as much as possible of not allowing any bias in the beginning. So now when you get a result, that result, comparing it to what your expectations would be from the actual hypothesis, that active ingredient X will be better than nothing or whatever, that you'll feel at least, okay, I did my best to make sure that I don't have to address all these other problems. Does that help at all?
To me, that sounds
great.
Basically like what I was attempting to say. And it also sounds like a way of saying that two ways that statistics interface with science are, number one, as a part of experimental design such that it allows you to minimize different sorts of biases through processes like random sampling, and two, that it allows you
comparing
different ways of analyzing results.
Yep. And a lot of that just comes down to seeing what the difference is between a particular measure and, say, what's called a descriptive statistic, like an average, and then taking that with respect to what the spread of all the data is. So you want to know where you are relative to what the central tendency is of your data sets, as well as how far along the extremes your data set go, and where are they clustered and where are they sparser, and where does the data point itself fall. You had lots of questions at one point earlier before we even, like yesterday, or maybe it was this morning or something like that. Did you want me to address any of that kind of stuff? You've already asked what statistics are. Like, what are the, do you care about any of that? Should we move on to something else, or do you, because that seems like I've mentioned a lot of things like central tendency and all that kind of stuff, and I don't know if that's someplace where you want to stop.
What do you want to talk about tonight?
Well, you know what? I got really into the whole idea of answering a lot of your questions, and so in some ways I'm kind of in that mode of thinking because it got me working in that way. And so I felt like, oh, okay, I can try and help do something. What do you think about that?
Many of my questions involve details about what Wikipedia thinks statistics is. But when I do the general question, what is statistics, your answer to that was so different than the Surface 101 level internet resources descriptions of what statistics is. I didn't know how to go into follow-ups. Because there are lists of concepts that people talk about involving the mathematical statistics that I don't, like you were saying, central tendency or, population and distribution and that kind of stuff. And that's what I assume that's where that comes from. Population is like your data points, and then you plot them on some graph, and that's their distribution. And a central tendency is a clustering, and I bet cluster is also like a technical term. And
well, there are like cluster analyses, yeah. But one of the things I think should be said at the outset, like, what are the basic concepts? We're just thinking about just quantitative data sets and all that kind of stuff, like data that is, well, okay, I think at some point would probably be like, what is data, or whatever. And my answer would just be that it's obviously the plural of datum, and that a datum is just like a value again, whether you're doing a measurement or observation, that the variable assumes. And then, when we talk about descriptives, there's two different kinds of statistics then from this point. There's descriptive and inferential. And we've been going on quite a bit about actually inferential statistics. And usually if you're going to do statistics 101 or whatever, you're going to start out with descriptive statistics, which is just, like we were talking about, like the average, the median, you could say the mean, the median, the mode. There's different kinds of means. Like you can have a, geometric mean or an arithmetic mean, like there's different ways of calculating that central tendency variable or whatever parameter. So, but I just think of it as just like his processing and communicating of quantitative data sets. And that's kind of the idea to me anyway, when I think of descriptive statistics. Also includes the variance, which is a calculation of the variation, and the standard deviation, which is another derived calculation from the variance that also helps describe this variation. And you can also get things like error from there, statistical error. You can also get your confidence intervals and these kinds of things, which are all just trying to talk about the spread of the data. And then your inferential statistics, that includes the hypothesis testing and basically just like tools and techniques for how to relate quantitative data to our ideas. Like that's kind of what inferential statistics is to me anyway, as far as I could tell. So that's kind of that stuff. Population in statistics is sort of the actual number of events over you could say some time period if you wanted. This is like all the fish in the lake, but you can't likely count all the fish in the lake, let's say, if you're just going up to the edge of it, but you want to get a sense for how many fish there are, or maybe you want to know what's the length of adult fish. Do they have an average length? Do you want to break it down as to male and female or whatever it is? And so you take a sample and you make sure you mention whether it's a male or a female or how many years, if you have a way of detecting that, how old it is. And this is like a collection of the events that belong to the population itself. But the idea, I think, in quite a bit of statistics comes down to the notion that you'll never have access to the whole population. You'll only ever have the sample. And especially when it comes to scientific problems and questions of that nature. And so in a way, that's sort of I think where this idea of all models are wrong comes from, is that you're never going to have all of it. You'll just have some of it. And maybe you can do something useful with what you do actually end up collecting. One of the big things that I think he talked about was that sort of idea that can we assume, or can we even feel even more confident in saying that the distribution of the data in a sample is the distribution that exists in the overall population? Can I just collect a bunch of fish and then say, yeah, this is probably what the mean is for the population? So there's a lot that goes into it in that sense. But anyway, that's sort of, I kind of feel like one of the hardest things about math is talking about it without actually writing it down in front of people on a board. Like, it's just really like, that is one of my missions in the Dawdlers philosophy, is to find a way to talk about math without actually there being any visual component.
That's a good challenge.
It is a good challenge. I don't know if I'll ever get there. I should scour the net and see if anyone's actually got a good idea as to how to do that.
I've heard from multiple other sources that that's a hard problem. Some people will even claim there are certain concepts, certain questions that you just can't talk about, can't understand, can't address without knowing the math. You just have to use this particular language game and these symbols, and you have to learn the manipulation rules, and you have to be able to do this. I can't talk about it otherwise. And I am resistant to buying that. I figure, well, you're just not good enough at English or something. There's got to be a way. English is pretty powerful. I bet you could say it if you had the right words and were a good enough poet.
Well, I want to address that, but I don't know if now is the time to address that stuff or not. but I guess I'll just go into it. That sounds to me like what George Box talks about R.A. Fisher calling Mathematistry. The idea that it's just pure mathematics and you're just dealing with the variables and the mathematical relationships on their own and just doing stuff with them and not even thinking about or caring about their applicability to quote unquote real world problems, you know?
Mm-hmm.
And so it might be that it's, I don't know. I mean, impossible. We've already covered that. That's not something any one of us is going to hold to. But I think that it is quite a hard problem if you're maybe in that realm where it is just the symbols and stuff. And you know, without being able to show, it's hard to tell. I would like to think that it's possible because that would be great if there was a way to do it, because then you could talk about it and maybe it would be kind of exciting, but I'm not sure. I think that even having a rudimentary elementary school level of math, for instance, would be okay. Like you should be able to, like, if I say A divided by B, you should be able to picture that, right? Like whatever that would, you know what I mean? Like that shouldn't be like, what? You know, just talking about ratios, you know, it shouldn't. And since people love money,
but no, I don't
think that like you know, they would be able to do calculations to an extent. But then again, you could always come back and say no one's any good at dealing with money, so whatever.
I think that we could English division that without knowing anything about arithmetic. Talk about a flock of sheep in a field and building a fence. Well, now we've divided these sheep from these other sheep. There's a barrier in betwixt. There's a division now. There's these over here and those over there. And then if you build another fence here, okay, well now we've got two fences and we've divided them more. There must be ways to use common...
But how do you...
Yeah.
How do you do, like, I guess you would have to then say, for what I think most of the time, you know, you might do is like, what about like the whole, like, so say you just build a circular fence around like a small number of sheep in a field, and then you build a fence around all the sheep. And so you want to talk about the small fence in relation to the big fence, which would include the sheep in the small fence. You know what I'm saying? Like, okay, so that's 1/6 of the sheep are in that small fence or something, like, you know what I mean? Like, see, it gets complicated enough, but I still think that there's got to be a way. Somebody has to have tried that. Somebody, you know, and so I just have to go and try and find them.
Yeah, just watch old Sesame Street episodes or something.
Yeah, fucking Oscar tried it. Oh, yeah. Anyway, so nonetheless, that's kind of boring stuff about descriptive and inferential statistics. Well, actually, no. I think the descriptive statistics are the boring stuff just because they're so simple and basic, and they don't really say a whole lot in a way. People love them in sports and stuff like that, but I think the inferential stuff is kind of where the rubber meets the road, where you're trying to do hypothesis testing and really trying to control complicated systems.
Trying to control complicated systems by
epistemology,
applying inferential statistics to your decision procedures.
Yeah. I mean, it's all very. I mean, we're all very much, I think, in the realm of epistemology here, and so it's just just trying to get some semblance of order in what it is that you have gone about collecting, and also comparing that to what you're thinking, and that's what I would say.
It sounds the way you're talking like we're in the realm of Texas Hold'em, at least in my brain. That's pure inferential statistics, right? First, you've got to know the basics, like the distribution of cards in the deck and how many players are in the hand and how many are known and unknown. And then you can add to that the Bayesian aspects, I suppose, of the history of the betting patterns of your opponents and how have they behaved previously. oh, well, the odds of them having a couple of 7s are X, but the odds of that person having them are plus or minus Y because of how they typically behave. They're a loose cannon or they're tight and blah, blah, blah. And it's all about attempting to use different types of statistics to make different types of inferences in order to develop behaviors, betting patterns, that will be long-term successful over, make the right move. You'll always say, well, you can't base it on any hand. You could get screwed on the river, but it's still the right play. Because were you to run that on 1,000 iterations, you would profit by this margin, blah, blah, blah. I mean, that's one place where many people at least will be familiar with some aspects of statistics, is games.
Without question, yeah. You wrote at one point, experimental design and the arguments from absurdity. What did you mean by that?
Arguments from absurdity is a phrase that I got from this guy, Rai, a co-host of the Dawdlers Philosophy Podcast, this like kind of half-assed attempt at being intellectuals by these nobodies. But that one of them would often reference certain tendencies of certain philosophers to make ridiculous or absurd arguments. Often skeptics will do this. They will posit something that we have no reason to suspect, but cannot be conclusively falsified, and use those as premises in their arguments. We briefly I talked about it a little bit earlier. That's what I was calling the critiques that some would point toward experimental science. That, well, you never know, maybe you are running your experiment in a laboratory that happens to be in the tractor beam of an unacknowledged alien spaceship that is altering the atomic weight of hydrogen in the region of your laboratory, but it's different across the street. Whatever. These absurd possibilities that you can't rule out. Maybe some would say shouldn't have to rule out. They should just be assumed. These simplifying that, and that your answer, I think, to the arguments from absurdity are the simplifying assumptions you brought up earlier.
Mm-hmm.
But by writing that's what I was thinking of, that there are potential lines of critique against, you can design whatever experiment you want. You might be wrong about what you have achieved with your design.
Well, wait a minute. I mean, it's just another model. I think the idea is to say, this is what I went about doing. Some of these particular moves, these are the reasons why I made them. And if these things all are agreeable, we can then move forward and talk about the results of the experimental test or whatever it was. When I say you have better control of complicated systems, it just means that you have a consistent way of working with them, in that you can say, well, I did X, Y, and Z. Maybe that's not the best way to go about it, but we have a record now of going and doing X, Y, and Z. Maybe we have a record of doing X, Y, and Z 50,000 times. Like in any case, we have that record. We can say we've gone there. We've shed light on that. And now we're going to move over and shed light elsewhere because we got some good things back from the result comparison to the what we expect to get. But we want to improve upon that even. And so we then continue to improve our experimental design, so on and so forth. So arguments from absurdity then are just like way out there, and it's nothing we can control because, again, it's an alien spacecraft, invisible. It has its cloaking device on, and it's got this tractor beam or something like that. It's just beyond the control of early 20th century agriculturalists, but we're out here muckraking, and we can talk about that.
Yeah. And that's fine to me, as long as one is willing to make that move that Box makes and just say, I'm not even aiming at truth. Fuck that. All models are wrong. I'm just trying to make something useful through this process of iteration and comparison between theory and practice and do a little better than I did yesterday. That's all So against that sort of person, these arguments from absurdity are toothless because they only work against dogmatists. That's their target.
Right. Yeah, that's their target.
Yeah.
Totally. So do you feel like you still are missing something, or that those who are ignorant of and somewhat resistant to doing dirty field muck raking and persnickety symbol shuffling, where do you stand on that now?
That remains to me a question, and it's just a opinion thing that I'm curious of what your opinion is. I've heard various opinions from different people at different times. Some of us don't, quote unquote, know very much about mathematics. I have access to the internet and some amount of free time. If I made the choice to, I could learn math, like advanced math. I know how to do basic statistics and arithmetic and whatever, and I took calculus in high school and blah, blah, blah. However, in my day-to-day life, I don't use very much advanced mathematics, and I remain unaware of it. I don't have an aesthetic taste for it, and I have this vague hope. Maybe it's only a hope, I don't know. I should see if I can develop what sort of argument I could develop. But that I don't need to know advanced mathematics. I can do everything I want to do in what we call philosophy without having to worry about it. For example, one of my prior acquaintances and I would discuss what they call, quantum physics or quantum computing or the philosophy of the mysteries of quantum, whatever. And I was taking the side that I don't need to know what a complex imaginary number is in order to have reasonable opinions about quantum mechanics, quantum physics, quantum computing questions. My acquaintance thought that I was wrong about that. Unless you learn the math of quantum physics, your opinions are pretty much useless. In order to even conceptually comprehend what's going on in this domain, you need to learn a given language. So I'm wondering kind of what your opinion on that is. Those of us who are ignorant of math by choice, do you think we will always be missing, lacking something? There'll be a certain domain of things that we cannot address, or, you don't really need it. I mean, it's nice if you want to do if you want to publish in this journal, or if you want to do actual experimentation, you might want to learn the math. But for a philosopher, you're fine. You don't need it.
I don't know. I mean, there's actually a lot to say here, but yeah, I have a lot to say, interestingly enough.
Well, then let me crack another beer.
I think first off, I just want to say, I think there are some philosophers, it's hard to tell if they're philosophers or physicists or both, and I can never remember this gentleman's name. He's kind of got long, or at least it's longish hair, usually kind of salt and pepper, and he's a quantum guy, but he also is a sort of, I guess, a philosopher. And I wish I could tell you more. Maybe you would know his name. But
Tim Maudlin has kind of long hair, but it's not really salt and pepper.
I don't know. I can't. He's a semi-public intellectual. This guy who I don't remember his name. You're welcome, America and the world. The world. Sorry, I forgot. Anyway.
I'm David Albert. I'm a professor of philosophy at Columbia University.
So, but he was just saying, when it's like three equations, he sends the, 3 equations or less, he sends his paper into the philosophy journals. If it's more than 3 equations, he sends it to the physics journals or whatever.
I remember that little cliche, yeah.
So there's that. And then I think Michael Faraday is responsible for essentially things like electromagnetism and understanding electrochemistry and all that kind of stuff. And he didn't know any math. He just used his brain, to do it. He didn't use any other particular tools that I mean, he may have used lab equipment, but in general, I think, he did it all without math, and it's a huge contribution to physics, right? So there's that.
I'm told that Einstein wasn't much of a mathematician, at least at first.
Well, as I understand, and I wish I could pull these quotes from someplace, but I remember him complaining that why do I have to do the math? It's already in my head. Like he's like, I'm already there, that kind of thing. And so that was a frustration. And then people would say his math was clunky, and he's like, I arrived at the solution for you people. Like, like it's there, it may not look pretty, but there was that. I don't know. I mean, could somebody like a Michael Faraday be, I don't know. Could there have been a Michael Faraday for quantum physics? I don't know. I mean, that's an interesting question. I think, though, that quite a bit of the physics, which some of it was initially, as far as I can tell, done by Einstein himself with the photon, I think it was a lot of it was just figured out mathematically. And then from there, people gleaned whatever insight they were going to glean about systems from the math. But I'm not certain about that. But I do think that quantum physics, at least, is drenched in gleaning understanding from the mathematical approaches that were used. That could be cultural. I don't know. You know what I mean? It could be like specific to the people doing the quantitative stuff. And, it just happened to be that there was some mathematical tools, statistical tools in particular, that were used to try and understand crazy subatomic behavior, and it was taking different variables and putting them together and seeing what output were that was crazy, because your expectations would be different than maybe what some of the results turned out to be. Spooky behavior. And so now that we have that information, right, now that we've gleaned from it what we know or understand, we can still, I think, describe it, and it can still be understood. That would be my position. Not that you would absolutely have to have math, the understanding of the mathematics to understand the behavior, because I think that's the whole, eventually it gets taken over into the realm. That would be quite a thing for only those who understand it mathematically to wield or hang over those who don't. That would be some interesting power play if scientists actually were greedy in that way, which they aren't. So that's like totally that is like the premise for all like futuristic-y kind of villains in like comics, right? They just like develop their gamma ray, or when it's, they like wield it against the world. Anyway.
But weren't you having those suspicions or considering that position earlier when you were talking about, wouldn't it be nice if I could find a way? One of the challenges I have on the Dawdlers philosophy is to describe concepts that are typically accessed through mathematical manipulations in non-mathematical ways.
No, I want to know how to speak math in English. Do you know what I'm saying? So I
can't speak English in English, because that's what I just fucking said.
What? I mean, oh yeah. No, I mean, not that, like, for instance, when we talk about the population or whatever, or, some other kind of like taking the average, we can talk about central tendency, right? And we could talk about variance by talking about the spread of the data. And anybody can kind of have an idea about, spreading something out, right? And anybody can talk about like things clustering together. So we can use that to talk about the concepts. But I'm literally talking about the actual equations. Like, how do I say the equations in a way that people then understand what I mean? And that would be awesome. Because then you could take that and sort of talk about the concepts as well, rather than, I don't know, that's the biggest thing. That's where I've always come from in my own searchings, if you will, is I want to know how the calculation is done, because usually people have something to say about things, but they say it in a way that makes sense in English. But then, it's like, yeah, but how did you calculate that? Oh, well, like, and so you kind of want to know the details. Well, I do anyway. So that's the issue. Things are communicated in various ways, and I was wondering if there's a way to communicate. Like, for instance, if I was to say the sum of all the data divided by the total or something like that, and that's the average.
I have low confidence that this will be a useful contribution, but you know those videos that they will show in psychological experiments where all you have is a sort of bell curve looking shape and a triangle and a circle or something, and then you play it as a cartoon and there's some motion, and the circle is trying to roll up towards the top of the hill and the triangle like pokes it and it rolls back to the bottom. And that through this very minimalist geometric representation, most audience members will tell very agent psychological based stories about the triangle's a fucking asshole. The circle is just trying to go where it wants to go and it was a jerk. And but, you know, all the is in the actual data is just shapes and motion and whatever. So given that sort of thing, I don't know if this is an avenue that you might explore in your project, but a possible answer might be make a narrative. Characterize these things. Make them agents. You know, oh, well, F equals MA. Well, F is for the fabulous Phineas, and he was this knight and had a sword and a white, and tell it as a story. Perhaps, I don't know if that's might be part of an answer.
Might be part of an answer. Yeah, I mean, there definitely is. I thought of things when you said that. I don't know if they were aligned with what you're actually saying. I hope they are, but definitely thought of things. Well, this has a lot to do with all models are wrong, but some are useful. Off-roading. Anyway.
So your answer to my general question, I guess, was you don't think that mathematical ignoramuses are necessarily benighted from a certain conceptual realm. That you suspect that we should be able to get there with English alone. It's just a challenge, perhaps, to express certain concepts in English, and it would be easier if you first went and learned some sub-branch of mathematics.
Let me put it this way. I suspect that you can, well, I'm pretty confident that you can get to the same places through other means, English being but one. So I would say, you know, rather than pitting simply English against math, that there might be other ways to think. I think about Temple Grandin. She's an autistic woman who is probably, I don't know how old she is now, but she's a biologist, and she came up with lots of ways to come up with, you know, ways for domesticated cattle and you know, sheep and whatnot, livestock owners who are going to bring these animals to the slaughterhouse or bring them to be branded or whatever it is. She came up with lots of different ways to make the animals, number one, feel better about what's happening, and number two, make them easier to handle by the people who are trying to move them from A to B or whatever. And some of the things that she did are very geometric, but she doesn't use any math. And she also, I think, to an extent, somewhat struggles with English, but she uses this other way of getting at these problems. She came up with this one spinny thing for how to get cattle from one place to another, and is to like keep them moving in a going left or whatever. And so then they kind of get shot out into this other pen or whatever. And it's a way to just make it a smooth transition to get them from one place to another or whatever. So, I mean, and she just thought about the geometric shapes, and she also thought about what it would be like maybe possibly for them, you know, based on other information that she had about them. So that's kind of another way to solve the problem without you necessarily using English, but it's not math in the, you know, symbolic way of doing math, you know? So anyway, all I'm trying to say is that there's other ways to possibly arrive at thinking of a solution, coming up with a solution to a problem. Some of it could be math, some of it could be English or any other language like that, or some of it could be this kind of geometric spatial thinking or whatever.
You weirdos who say you think in pictures.
I love how you always go, who say.
Yeah,
well, I mean, you're using the English language.
Because I say that I'm the sort of person who thinks in words to such an extent that I can't even comprehend what these other people who claim they think in pictures are talking about. I don't even know what that would be like.
That is so strange to me. I would think that there's more people who don't think purely in English or whatever. That would seem like you've gone beyond, above and beyond. You know what I mean? Like you're evolved, Harland.
I try.
Right? Because you would think that before there was language, even maybe before there were convincing grunts, organisms had to do something, with their nervous systems to, whatever's going on in their brains. They're calculating as they're chasing after prey and anyway, whatever.
Competence without comprehension. Bumper sticker.
Yeah.
You have anything else you want to say?
No,
I have two things.
That is so good. Classic. Hit me.
Number one is a quote from the box paper.
A group of people can be kept quite happy playing with a problem that may once have had relevance and proposing solutions never to be exposed to the dangerous test of usefulness. They enjoy reading papers to each other at meetings, and they're usually quite inoffensive. But we must surely regret that valuable talents are wasted at a period in history when they could be put to good use.
Is he talking about me?
Yeah, I think no. I was going to say, is he talking about what you think philosophers do?
Yeah, I was like, that sounds to me a lot like philosophers.
I totally thought the same thing when I read that. I was like, oh, that's great. I think so. I think that's what he's talking about. You muck-raking mathematistrists. But then the opposite is the cookbookery thing,
Not opposite. He calls both of them maladies.
Well, yes, they're both maladies, but well, I guess you're right. Maybe cookbookery does the same thing where they just keep applying the same damn fucking method. To an extent, I have Go ahead.
His definition of cookbookery is
The tendency to force all problems into the molds of one or two routine techniques.
Just sort of, when the problem comes up, you go to the cabinet, you open it up, you pull out Betty Crocker, and you say, how do I make a fucking blueberry muffin? And then you flip to the page 274, and you do that.
Yeah, no, for sure. Yeah, and I was going to say, you're like, how do I make a blueberry muffin? And you would be like, premises and conclusions, of course. Yeah, I think that's... But, it's funny. When I think of the cookbookery thing, I think of more of the scientists who learned a few methods in their dissertation when they were doing their PhD or whatever, and they really learned them well. And at the time that they learned them, they were kind of the centerpiece of their field or whatever. And so now wherever they go, they just apply those methods. And somehow they're like, we'll just apply these methods here and we'll get our results and everything will be great. And we'll publish those papers and blah, blah. That's kind of sometimes what I think about cookbookery. Because one of the things he talks about with his love of Fisher, this box guy, is that, Fisher was not satisfied to do that. He was always trying to artfully apply math to the problems and try and solve for a number of issues that arise when trying to do any kind of science on the muck raking or whatever. So that was kind of something that I kind of picked up on as well, was that I just kind of thought, oh yeah, that's kind of those people that just kind of, are just coming out, and just everything's a nail to their hammer because that's what they know.
The quote that I liked about that, I think that is about that.
Pure mathematics is concerned with propositions like, given A, does B necessarily follow? It has nothing whatever to do with truth nor real life. In applying mathematics, we make assumptions about the real world which we know are false, but which we believe may be useful nonetheless.
And that's another way of his, to express the models are wrong but useful.
Yep. Yeah, he says it all the time in various ways. It's hilarious, and in different venues for different audiences. And I imagine that for these kinds of papers, he would just cut and paste things he's already said, and put them in different ways. And anyway, I'm like, and that's why science is better.
Yeah. So anyway, I wanted to get that little insulting paragraph about philosophers on there. I liked that one. Number 2 of the things I wanted to do while we're here, because I'm going to it's not relevant right now particularly, but I'll forget it by next time.
Okay.
So I want to ask, what's your take on my proposed current definition of mathematics that conveniently I think you have a text version of for the listeners who won't be able to follow all. Anyway, so is mathematics a system of symbols and manipulation rules such that there is a pragmatically useful degree of isomorphism between the behavior of the symbolic model and the set of phenomena that some community intends to describe and or predict by the employment of that model? Is that a fair definition of mathematical modeling in science?
I think so. I think I also decided to try and come up with my own. And you tell me if what I'm about to say matches with what you've already said.
Okay.
I would say mathematical modeling. What a couple of jerks we are. Is
That's why everybody loves listening to it.
I would say, to me, when I think of mathematical modeling, because I wasn't satisfied with what was said about it, not you, elsewhere, it's the use of numbers and quantities to determine relationships and outcomes within and between symbolic systems. Does that make sense? Does that help you? Does that say what you were saying?
You probably have to say it again. It had the word determine in there, and it made me balk.
I don't know, estimate, is that better for you? The use of numbers and quantities to determine, approximate, estimate, to, come up with a value of the relationships and outcomes within and between symbolic systems.
No, God! No, God, please, no! 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 No!
So you don't seem to have quote-unquote reality, the world, anywhere in there. It's all just symbols. And that mathematical modeling is a mediating mechanism between different symbol systems.
Well, it's the use of numbers and quantities to determine the relationship. So it's kind of like modeling. That's not, mathematical modeling is modeling, but then there's things like model validation where you then take it to, say, a data set to see if the output based on the input into your model gives you something. And then you can say, well, how does that compare to actual data across a similar kind of thing? You're trying to come up with a model, and then you can say, does its output do anything elsewhere against data that we may already possess? And if it compares relatively nicely to it, then you can say, okay, well, I kind of like this model. There aren't any others out there that are as good or even like it, and I think it helps us address other problems. So now I'm going to take it and put it someplace else, and I'm going to talk about what the output might be given various scenarios or various changes to the variables, that kind of thing. That's kind of what I was thinking, but that may not be right. I don't know. I mean, it may be partially right or whatever,
I'm wondering if you have anything in your definition that plays the same role as the clause, the set of phenomena that some community intends to describe has in my definition.
Yeah, I don't do that.
I feel like
I don't do
yours.
Yours always
that's
has
my
to have...
version of reality. A regular person would just say, the symbol system that usefully is similar in structure to reality.
But I would
basically.
I don't know. I mean, to me, mathematical modeling, I don't know if it necessarily has to model reality. It can model a model could model a model of that model's a model. I don't know.
Right.
So I was just thinking that just in the sense, I was just using these quantities to determine relationships, and work out outcomes within and between these systems. I don't know. I guess
outcomes also means more to you than me. That's a word that's a term of art for you that I don't appreciate. What's outcomes?
Outcomes is just the output of the model. And so you're looking at the output, and if you change certain relationships between variables, maybe you remove a variable, maybe you put one in, you're wanting to get a sense, okay, F equals M times A. That's a mathematical model of force based on mass and acceleration. Can you get another estimate of force using other variables besides mass and acceleration? And I think you can. There's lots of different ways to. You know what I'm saying?
Mm-hmm.
Okay. So I should have probably thought of examples to apply it to. But the one thing that you like to do is you like to involve the community, and we're talking English and all that. And I'm like, fuck that shit. Just, go pure.
But that's what's happening. You can't get out of that.
Well, no, we're in it.
Yeah, because you're in it. So mention it.
Why? Why is it that?
Because otherwise you're a fish.
Yeah,
swimming in the water that you don't know is there.
No, we just removed the part where we don't know it's there. We just kind of, we don't talk about it because we don't need to.
If you don't talk about something, you forget it very swiftly.
But
I think we need to make this stuff explicit.
No.
Lest we...
I think we just need to have a philosopher on hand to be like, what's least in least squares? Oh, God. Just to remind us that there's fucking explicit things that you want with you and Alfred George.E.P.
It's easy to become hypnotized by language, so that we need to keep mentioning that, oh yeah, we're all swimming around in a bunch of water.
It's
yeah,
uninspired.
Right, okay.
It's not fun. It's not interesting. It just is kind of bogs everything down in extra details, and you just kind of don't even want to bother. That's why I don't like it.
Not everything has to be fun, you punk. Kids, goddamn kids, get off my lawn.
Yeah, I know. Jesus Christ. I want something aesthetic and pretty. And I know there's lots of scientists out there like, just because it's pretty doesn't mean it's true, or whatever.
Just because it's pretty, you should doubt it extra. Because being pretty just means tickling your chimp. Your aesthetic judgments are not determined by any cognitive mechanism.
What?
You don't choose what you think is pretty. What you think is pretty is determined by something out of your control.
Well, that's
your
fine. I accept
evolutionary and developmental heritage.
Absolutely.
And that's not something that we ought to epistemically value or trust in any way, because that's not it doesn't track anything. What?
It starts.
Get out of here.
No, absolutely not. It's it may be that aesthetic appeal or whatever is a chimpy quality, and I'm fine with that. I'm not disagreeing, but it's a quality that brings me closer. Otherwise, I'm not gonna go towards it. And I am a little wondering if your whole aesthetic quality is just different, and that all this explicit detail and the consistencies and all that kind of shit is all just something that is aesthetically appealing to your chimp, and we're all just a bunch of fucking chimps. And so long as we keep moving forward and we keep talking to each other and having dissonance between our different aesthetic appeals, then we start to maybe let ourselves kind of get acquainted with our biases and maybe become a little more honest and try to do a better job as much as possible, even though secretly we think the Earth is only 6,000 years old or something like that. That's a joke from the
inside
fucking,
joke for Dawdlers fans. One critique that I've received about this podcast, to get a little meta, is that we agree too much. So here, perhaps we found a region of current disagreement that we could attempt to resolve in a future episode.
Why Harland is wrong. Episode 23.
The best one. Save it for 23.
I don't know.
I think there might be some stuff here to talk about.
Okay. Sounds good to me. I can't tell if this was like, if we were just muck raking through this whole thing, or if we have done something special. Probably not special, but I don't know. That's the first word that came to mind.
I'm told that it's best not to attempt to evaluate your own work. Just fucking do it. Push stop on the cassette, eject it, put it out into the world, and let them decide.
Cassette? What are you talking about? Cassette? Be clear, man. I don't understand. Your listeners don't understand you.
For those of you who are under 32 years old, there used to be these things called cassette tapes. It's like a VHS tape. Everybody knows that, right? Oh, wait.
Oh. Chuckle. All right, well. Till next time, folks.
Play an appropriate song. Why don't you?
All right. And go.
Ой, du hast mich eine Stechele. Du hast mich gefragt, hab gar nicht dir gesagt, willst mir sein, geht rein,